Okay, happy Halloween, everyone. We're going to begin chapter 5 here. This is actually a pretty short lesson. And before that, I found this video on YouTube of a pretty cool costume. Go ahead, type that link in, check it out, followed up by the making of costume. Pretty cool stuff, so if you enjoy that, enjoy. Take a look at chapter 5. What we're going to look at today is exponents. Chapter 5 has to do with polynomials. That means numbers made up of several other numbers. A lot of these have different degrees, i.e. different exponents. So this is just a little review on exponents. A lot of the stuff we should know how to do, but again, we just want to make sure we're at a good, comfortable level with this. Okay? Let's talk about exponents. The base number is the bottom number down here. The exponent is the 4, and then 2 to the 4th power, the whole thing is the power, okay? So that's obviously 2 times 2 times 2 times 2, which is 2 to the 4th, which is simply 16, okay? So 2 is the base, 4 is the exponent, and then 16 is the power, okay? All right, so here's some different things we should know how to do. If you are multiplying bases, then you are adding exponents, and that's x to the 5th power, 2 plus 3. So you're multiplying the bases, you add exponents. Here, second one, we have power, okay, power to a power. So x squared, then raised to the 3rd power, you multiply. So this is x to the 6. And again, we want to make sure we get understand the difference between those two. When you have division, you have 2 x's on top, 3 on the bottom. So really what you do is you subtract them. So you have x squared minus 3, which is simply x to the negative 1. Okay, and then we can have negative exponents. What does that mean? That takes us to the next one. If you have a negative exponent, you want to make it positive, you need to switch the position between numerator and denominator. So a negative exponent in the numerator is a positive exponent in the denominator. Okay? Then obviously x to the 0 power, anything to the 0 power is simply 1. Okay? So on the right-hand side, we have a little bit more complex, again, following the same rules. So let's go back and take a look here. Here we have a power to a power, but notice we have multiple things inside the parentheses. So we need to distribute that 3 to the x and to the y, to both bases. Notice the bases never change. The only thing that changes is the exponents. So I have an xy base in the parentheses. I have an xy base outside the parentheses as well. So this is x cubed and then y to the 6th power. So notice I am just distributing that 3 to the exponents. That's x to the imaginary 1 there if you want to put 1 in. If you have a fraction raised to a power, that's the same thing as x cubed on top and then y squared raised to the cube on the bottom, which i.e. is x cubed over y to the 6th power. So again, the exponent of 3 is distributed to both the top and the bottom. And you go ahead and simplify like you would before. If you have a negative exponent raised to a whole fraction, tells you to switch the numerator and denominator. So I'm just going to flip the whole fraction. So I'm just going to interchange the numerator and denominator. So we really have y squared over x raised to the positive 3rd power, which is simply y to the 6 over x cubed. Okay. So a nice thing to do is to get rid of negatives right away and put them in the correct position. Down here we have anything to the 0 power is 1. Even pickles to the 0 power is 1. Okay? So just to put that in there so you understand that it could be anything. Let's look at some examples here. So all these are examples combining many of those different elements together. So here when I see this one, what I'm going to do is I'm going to distribute the 2 to the negative sign, to the 4, and to the base of 2. So a negative squared is really a positive. And then we have 4 squared, which is 16. Then we have 2 to the 5th times, or raised to the power of 2. So that's really 2 to the 10th. Now again, if I want to back up a step, I could show this as just simply 4 squared. Okay. So we have a positive value, 4 squared times 2 to the 10th. Well, 4 squared is 16 times 2 to the 10th, which is 1,024. If I multiply those two numbers together, I'm going to have 16,384. And again, it's a positive value. I just put that plus sign in front just to remind me that the negative is also being squared. So two negatives make a positive. Okay. All right, moving down. If I see something to the -1, the very first thing I'm going to do is flip the entire thing. So I'm going to rewrite it. So I have 2 to the 8th on top, x, y to the 12th, and then we have 2 to the 5th on bottom, x to the -3 down here. Okay. Secondly, I'm going to start to simplify things. So I'm just going to rewrite the fraction. Combine similar bases. So this is 2 to the 5th on bottom, 2 to the 8th on top. So really it's 2 to the 8th minus 5. So we have 2 to the 3rd on top. Notice I can take this x to the -3 and move it upstairs, so it becomes x to the +3. This is x to the 1st, so we have x to the 1st times x cubed, which is x to the 4th. So again, notice I put it upstairs, made it positive, and added the additional x. Y to the 12th, that remains there, okay? And all I'm going to do is simplify this. I can simplify 2 to the 3rd power, which is 2 times 2 times 2, which is simply 8. 8, x to the 4th, y to the 12th. So I'm just simplifying that right there. Moving on over here. Anytime you have a multiplication problem, you can simply combine the fractions. But notice I had this -2. So I'm going to rewrite this back portion here. And I'm simply going to show it as, I'm just going to rewrite it over here and put x squared, y to the -5th on the bottom, and then y, let me erase that. We need to multiply it by 2. I'm going to do 2 steps in 1 here, actually. So I'm going to flip it and show it as y squared over x squared, y to the -5th to the +2. So again, all I did was rewrite that as a positive. Now, when I square it, I'm going to have y to the 4th on top, x to the 4th on bottom, and y to the -10th on bottom. And I simply can just add this fraction. Really, I can just make it one big fraction. And I'm going to copy down and do it in a different color. So I'm going to distribute the 2. So we have x to the -6, y to the +6, x to the 5th, y to the 6th. All right, now the last thing I'm going to do is simply just combine everything and put things in the right spot. So let's look at the x's. I have a -6 here, so I'm going to move that down and become x to the +6 down there. So I have 6 plus 5 plus 4 is 15. So x to the 15th on the bottom. Okay, now I'm going to look at the y's. Notice y to the 6 cancels y to the 6 because 6 minus 6 is 0, and anything to the 0 power is 1. So they can simply cancel each other out. I'm going to take this y to the -10 and move it upstairs to be y to the +10. So we really have y to the 14th on top. So this entire fraction simply gets reduced down to y to the 14th divided by x to the 15th. One more to do here. Now the very first thing I'm going to look at is I have to the 0 power. So this entire parentheses gets reduced down to 1. I'm going to put an imaginary exponent after that c and say, okay, c to the 3rd power times c to the 1st power, simply c to the 4th power. And then we see a b to the -4. I'm going to put that on the bottom as a +4. And again, you really don't need to show that 1, so we're going to have an answer that looks like that. So that would be the most proper. So again, this is a review of exponents. Again, this is stuff we should know from first year of algebra. But again, just putting it together. When we're working with polynomials in this chapter, at points we're going to have to reduce or compare exponents within the different terms. So we have to know how to do that. What I want you to do is try these 3 problems for homework. Again, just simplifying and reducing, and we'll start up our next class with these problems here. Okay? Have a great Halloween, and thank you very much.